Okay, our next discussion is going to be a panel discussion, and it's all about how design can impact the way that we take robotics and implement them into the real world. What role does that play in helping us address the real world needs of robotics, and what are designers thinking about as they start to navigate those challenges? I'm going to stall for a few seconds while we set down chairs. But going to lead this discussion is Tim Fernholz. He's an independent journalist, freelance journalist, and I'll let him introduce the panelists as soon as they're up. But yeah, we can go ahead and start filtering folks up. I think this is your microphone. There you go. Thanks, Tim.
Thank you. Hello, everybody. Good afternoon. Hope you all have been enjoying the programming thus far today. We are about to start a new panel discussion. Humanoids, designing work, trust, and co-adaptation. We have 4 speakers who all approach this problem from different vantage points, but they have all been...
I'm going to have you on the very end.
Oh, I'm in the wrong spot. Excuse me.
I'm going to have you guys trade places. Sorry.
But they all have practical experience designing and deploying humanoid robots, and a lot of important lessons, I think, for everybody who wants to see these machines leave their work cells and get out in the rest of the world with us. I'm going to briefly introduce our panelists, starting with Ryan Saavedra. He's the founder and CEO of Alt-Bionics, which is a company that makes dexterous hands for prosthetics and for humanoid robots. We have Matt Willis, who is the head of product at Agility Robotics, which has the first commercially deployed humanoid robot, Digit. You might have seen a presentation about that earlier today. We have Chris Kudla, who is the co-founder and CEO of Mind Children, which builds social humanoid robots that are intended for use in education, hospitality, and care settings. And finally, we have Pip Mothersill. She's a user experience designer. She works at MERPHI, which is a research and design consultancy focused on robots. Thank you all for being here with us today and sharing your perspective. We're going to start off with kind of a bigger question, and we'll start with Ryan. But we want to ask, when robot makers are talking about actually deploying products to the real world, are we thinking about how humans need to accommodate humanoid robots, or how the humanoid robots need to accommodate humans in their environments?
Q&A or something like that?
Yeah.
Oh, do you?
Okay. Let me get this guy.
No, sorry. Yeah, so big question. It's on everyone's mind, obviously, and I think the answer is going to be dependent, which is a fairly disappointing answer, on what the application are and when the timing of humanoids is actually going to be, right? So if you're trying to incorporate something into a warehouse where robots are going to be interacting with people, then that's the first and foremost thing you need to think about, and very quickly. But if you're looking at the far future of things, then obviously that can be kind of delayed and pushed back out. So it's very broad, but I would say, like, in a short-winded answer, like, it's going to be depending on A, timing, and then B, how much money you are going to want to spend to actually create that deployment.
Does anyone else want to weigh in on where to start?
Yeah, I mean, to the question, do we think about whether or not we need to adapt to humans or humans adapt to us? Like, absolutely. I mean, part of designing humanoid robots to work in any industry or any use case is about understanding the use case itself and the context in which it's operating within. So aspirationally, the promise of general purpose humanoid robots is to not require changes in environments and not require behavior changes of people to operate around them. And so for us to do that, I mean, this is all about infrastructure-free deployments. I mean, you would have heard earlier, if you were able to attend Paras's talk, that one of the key barriers is around how configurable your solution is to go into any of these environments. And I'm not even talking about humanoids here. I'm talking about any solution in any of these sort of environments that we're asking people to adopt to perform some sort of task. So infrastructure free is pretty important to us at Agility, because it means that we can get a robot to go into a place and perform a task without having to go and retrofit things or ask people to adopt things and these kind of things. But one thing that we've noticed is that people are willing to change tasks to adopt for the benefits of the machines once they're in that facility. And this is all about adapting to the fact that now you've just deployed robots, and now your operation has the superpower of these robots within them. And so you can start to think slightly differently about how you do your work. And so, one example would be, a robot can run for more than one shift. It's not 8 hours, then go home, that kind of thing. Maybe it runs for 2 shifts, maybe it runs for 3 shifts. Now you can start to think about, well, hang on, if I've got this workforce that's now running for 3 shifts throughout the day, how do I utilize the rest of my time within my facility? How do I utilize my existing workforce to take advantage of that? So what we actually see is people are sort of, opting into this sort of adaptation around, you know what, I can actually adjust my business in slightly different ways to get the benefit from it. But we didn't lead from that by deploying the robots in that environment.
Kind of happened naturally.
Yeah, I think I have a similar take on that, where that's sort of the point of the humanoid form, is that it's meant to adapt to our environment. And particularly at Mind Children, the first thing that then comes up is, well, when these humanoid robots are out in the world, then how are we going to interact with them? So we're looking at that social aspect of it, and what does a person do when they first meet a humanoid robot and they're not used to it? And they want to engage with it. So that's what we're focusing on. And I think in the same sense that it then opens up these other possibilities. So applications where you really want to have that social, emotional connection in order to do the task well. So for example, in education, we've seen young kids come up to our prototype robot, and they want to interact with it. And they're not looking at a screen to do that. It's this physical form. And then in healthcare applications where it is, you have to be very sensitive, and it can be difficult to navigate. These are the types of things that I think it's extremely important that the humanoid robot itself is adapting to these environments, and it's in these, especially initial use cases, not up to us to know even what to do with it when we're around them.
I think it's actually a cycle of adaptation. Hello. There we go. I think it's actually a cycle of adaptation. So, there will be some changes required by the human, especially as we're in this nascent period. And then, we will learn to adapt to them. They will learn to adapt to us. There's this balance of perceived expectations, then those expectations hopefully are met during interactions, but then we will maybe change our expectations as the functions progress. Then there will be this cycle of adaptation and expectations as we continue to coexist with these new products in our lives.
And, I think figuring out what those expectations are is really important. One story that struck me yesterday was someone talking about deploying a humanoid robot, and they would come back to check on it months later, and it would either be sabotaged or it had been broken and no one had tried to fix it, and it hadn't been doing anything for months. And it's clear that humanoid robots are a unique tool entering the workforce. And so I'm curious, when you're designing your products, when do you start incorporating user research? How do you figure out how people feel about your products and how that should influence their design? You want to start, Ryan?
Yeah, so I think it's from the very beginning. Like from the moment we started designing the product, we didn't go out there and say, I just want to build a bionic hand. We found necessary gaps in the market and in people's lives for bionic hands. We're also in prosthetics, so our company does very similar to Psionic, what they do. We started in prosthetics designing for people, and obviously there's a huge overlap because humanoid robots are an homage to human capability. And so from the very beginning, we were talking to those living with limb loss and the prosthetic community and anyone living with a limb difference. And we said, what are the biggest problems that you have? And so those same exact problems that they have are going to be problems that humanoid robotic companies will potentially encounter. And so from the very get-go, there was not a single moment in our company's life cycle where we weren't talking to people. We like to say we didn't design these hands, other people did. Humanoid companies did, people did. And so, yeah, that's our answer.
Yeah, I mean, the correct answer is, as early as possible, for sure. I mean, if you're not thinking about what the end application is, then you're going to try and fit a square peg in a round hole later on down the line. And so I think, some of this I get pretty passionate about, and people that know me and know the soapbox that I get on, so I'll spare you all from that, I guess. But a lot of other industries have sort of been thinking about this for quite a while. So if you take like human-centered design techniques and approaches that have happened in digital products and you apply them within this space, they're extremely, extremely relevant. And so, you know, one of the ways that we sort of approach this is we sort of, you know, you go and walk the facility, you go and find out what the problems are, where people are having a struggle, where people don't want to be working and doing these things before you even think about like, oh, that robot should be doing this task. And then you go and solve for those sorts of tasks. One thing I always tell my team is go and do the task. So I know when we were developing pelletization capability for Digit, you know, Digit's got to sit there and pelletize pellets all day long. We go out there and we watch people pelletize within facilities. We talk to them about, like, you know, what sucks about pelletizing, within these facilities. And of course, it turns out that you're asking somebody to lift 23 kilo totes all day long from a conveyor to a pellet, is that they don't do that very long. You know, they don't want to do that very long. So immediately you've found a spot where it's like, you know what, people are like begging for this kind of thing. You know, and then as you go through the requirements design process and you're sort of saying, hey, like how do we communicate within our teams and without, you know, what it is we're expecting Digit to do and what are the constraints that we're looking to do within. One thing I did was I got somebody to take a video of me pelletizing, you know, and immediately it's like, oh, I've got to stand in this position, I've got to move the tote in this way, oh, that's in my way, I've got to think about this, and all of a sudden you've got much more insight into what you're actually asking the robot to do and whether or not it's within the limitations of your product. And so all of that I just described doesn't require engineers, it doesn't require long development cycles, and you can very, very quickly learn the sorts of things that you're asking your robots to do.
Thank you. Okay, so I come from a product development background, so my answer is very similar to what you guys are talking about, but I had a quite a bit different experience over the last year or so. My co-founder is Dr. Ben Goertzel, visionary AI researcher, and we came together and he had this idea to build this completely all-powerful and super capable little robot that can do everything, costs nothing, and you know, like the best possible product that we could build. And I first said to him, we need to go and survey the market and understand what the actual needs are here and what we're designing for. And we couldn't come up with a good way to do that, though, because for social robotics and actually interacting with these humanoids, it's really challenging to know how someone is going to react or what they'll need or want without putting something in front of them. So we found this middle ground where we put together this proof of concept as quickly as we possibly could to get it out into the field. And what we're finding is I mean, some things are in line, but there are some surprises with what people really are attached to and gravitate toward, and what things we just totally missed the mark on. So I guess this is still in line with that. Like, it definitely needs to be an iterative process. But I think when you put something out just generally into the world and outside of a closed factory setting, it's quite challenging to know where to start in that respect. So that's kind of my somewhat different take on that.
Yeah, so as a user, researcher, and designer, I'm thrilled to hear everyone's like, as soon as possible. I mean, in terms of the functionality, absolutely, but also it's really important to think about the character design really early up front as well and get animating on that as well, because then those are the things that you can integrate some of the social cues that are going to be perceived by the direct users, but also the bystanders as well. How are you going to view something from a distance, you know, the silhouette effect? Even if it's got a smile on its face, if it looks like this looming creature from the distance, it'll convey a very different type of personality and therefore expectation for the users, possibly someone who's bystanding. And so designing for those characteristics really early on as well could potentially then trickle down into how even you're setting up the skeleton form of the humanoid as well. So trying to find a middle ground between technical functionality and the ideal human characteristics are really important. And that's where we can actually learn from humans as well. Not just like, the bodily mechanics of moving pallets, but like the facial expressions of those around. How do we infer how we co-work with people, how we socialize with people? There was this great story I heard about door-to-door salesmen where they intentionally waited 1 or 2 seconds after the door was opened to smile. Because if you open that door smiling, it destroys the whole reactivity situation. So there's a lot that we can learn from just watching humans in those social dynamics, a lot we can learn from animation principles, going back Disney many, many decades. So thinking about those first and foremost as well can really help set those ID elements and really core UX hardware elements that are going to allow us to do a lot of interesting adaptive UX design, interface design further down the road.
And I guess just to follow on that, did you want to jump in, Matt?
It's all right, you go ahead.
Well, I was just going to say,
it's your panel.
we've talked a lot about safety this week, or the last 2 days, as like a capability and as standards. But I guess I'm curious to talk about like perceived safety and how you can design your robots so that people trust them and feel safe and not just, know that they meet the standards.
Yeah, this is a both really nice segue and really good topic. I mean, if you look at Digit today, against a lot of the other humanoid robot companies that you sort of see on the slide and whatnot, it's an industrial-looking robot. It's a capable-looking robot, and that's intentional. Because what we want to be is to have a robot that's working in these environments that people are looking at and go, yeah, that can lift a 23-kilo tote, because that gives you confidence that this robot's capable of doing the tasks that we're sort of asking it to do. And you'll see some of that flow through in our design, in our future robot that we'll share some other time. But you'll sort of see that. But is that the right robot for other contexts? And my argument would be, well, no. You're asking for it to do different tasks. It's got different expectations to set and some of these things. When it comes to safety, it comes back to what Pip is talking about as well. It's both like, you've got a very sort of strong-looking, capable-looking robot. It can be daunting in some cases to be sort of around it. So you've got this sort of conflict of, well, hang on, it needs to be both capable-looking and able to do this 23-kilo totes all day long for 8 hours, but also be feeling comfortable around that sort of robot. And I think this does come back to sort of behavioral cues and some of the things that we sort of see. One story I always like to tell is we've all had that. We're walking down the hallway and we're sort of doing the little dance with someone because we missed the nonverbal cue on which direction they were going to head. One thing I always reflect on is I'm Australian. I don't know if you picked up on that. When I first moved here, I kept walking into people on the street. And I thought to myself, wow, that's really strange. Like, why do I keep walking into people? What's going on? And then I noticed that I kept walking up to the escalators, and the escalator was coming at me instead of the way I would expect. And I thought to myself, my navigation planner really sucks. I need to sort of recode this thing, And really what this is that my cognitive model of how you move in the world is different to everybody here because we drive on the other side of the road. And I'd never thought about this before, but people pass each other on the other side. And as soon as I cottoned onto that, I retrained my nav planner, I was okay again. I started not walking into people, and I thought, okay, this sort of works. And so understanding...
And the second data point on that being British.
Yeah, there you go. And so, these kind of insights are the sorts of things where it's like, hey, if we're going to train a model on behaviors, expectations of behaviors, we also need to understand the context in which we're training within and what some of these social cues and social rules are. So sorry to wrap this back into safety, it's the same thing. You've got to be predictable. People that I were walking into on the street didn't want me to walk into them, and I sort of shocked them and like, hey, what's going on? Whereas as I adapted my nonverbal cues to being on the correct side, of course, no one even noticed that I walked past them. And that's what you're aiming for. You're not aiming for designing, you need to acknowledge those edge cases, but you're designing for the time where you walk past somebody and you didn't even notice. Like, that's the time you're successful. Good design, no one ever notices.
Yeah, I have a little story about that as well, just real quick. That so at our booth today, it's me, 2 other engineers, Yue and Niall. Yue and I were working on the navigation for our prototype. And we thought we had done a great job, and then we showed it to Niall, and he said, you really need to, whenever you're going to turn right, like the arm kind of has to go to the right and make these gestures so that you don't just start running into people. We're like, okay, that's a really good point. Thanks, Niall.
And Ryan, I just wanted to ask you, I feel like when you are designing prosthetics that are actually attached to people, having them trust that is really important. And I'm curious if that carries over into applying the same technology to humanoid robots.
Yeah, so hands are an extremely subtle but extremely important part of our daily lives, especially with social interaction. Like, there's a difference between putting a single finger out the window on the highway to someone to indicate that you're angry versus, you know, putting your hand over your heart to express a heartfelt gesture, and it becomes more sincere that way. And so form was a huge thing, and you can ask our CTO, Jackson Hines, at our booth, or they were at booth 510, but we kept going back and forth on what the hand should look like. It was the longest part of the design process for us of what it should look like, because we wanted it to look robotic, we wanted it to look durable, robust, but we also needed it to look friendly and safe, right? Because there's hands out there that we've seen that are probably 3 times the size of this one that look like they're straight out of RoboCop, and like I wouldn't want to like shake that hand. But this one, you know, we designed everything down to, which was more semantic than not, but down to like how much heat the hand actually put out to give like a warmth sense of touch to the person who was like touching it, if you're interacting with like a child or someone else, and that was something that was carefully chosen. So yeah, it's the perceived safety of it, but also just the perceived image of it. Like they go, not to be puns, but like hand in hand, right? You can't kind of disconnect them without consequences. But yeah, very important part of it.
I think another theme in the last 2 days has been how important deployment is. Getting robots into real scenarios is a key way to learn about them. And I'm just curious, from your experiences deploying robots, what are practical things that people need to think about? And particularly, what are ways that you incorporate lessons from deployment back into the design of your humanoid robots?
Yeah, I mean, this is the product solution part, right? Like, you know, I'm a massive robot nerd. I love robots, have for a while. I am also a skeptic of humanoid robots, and that also steads me well as a product person, because, you know, you have to be a skeptic of your own product. But really, like, deployment of robots isn't just about the task. I've seen lots of amazing talks about, you know, manipulation and task-based stuff to make these robots do some pretty amazing things. But deployment's about integration within a facility. It's about understanding what the integration point is so that you can get a task done. So I'm talking about things like integration with the WMS so that I can receive the tasks so that our fleet of robots knows what work it has to do on that given day. It's about integration of other systems so that as I interact with a conveyor or a scanner or something else, like how does the robot understand and utilize that information to its ability? And then, of course, we've, you know, a common theme that you've heard everybody talk about and that Agility is very, very focused on is the safety story. And part of that's because the real unlock is going to be getting outside of these work cells and conducting multiple tasks. And so you have to understand, like, what does it mean to do those tasks in the facility? What are the key business drivers for this thing? How does this solution fit into that? How do we communicate the KPI metrics back into their BI tooling? So it's all of the stuff that, you know, might not be as fun to talk about, but is critical in order to actually deliver the value at the end of the day with a solution in that environment. And I think that's where we all sort of need to focus.
Yeah, and on the hand side of things, we have the unfortunately difficult task, much like general purpose humanoid companies have, of trying to ensure that humanoids can interact with the world that was built for humans, by hands, for hands. And so with that, yeah, there's just, sorry, train of thought, just like when, there's so many things I'm thinking of. Yeah.
Well, I guess just curious, maybe Chris, you could talk a little bit about when your robot sort of enters a new environment. It's particularly designed to interact with people socially. And as we're talking about humanoid robots moving into, you know, potential education or care or hospitality roles, how much emotional labor do they need to be designed to do?
Yeah, so, well, I think there are a couple sides to this. So to the prior point, maybe first, that we have a lot of unique requirements for different environments. And one of the big ones, we're looking at education first. So this is really challenging to bring to bring a camera into a classroom. So it's really important that these types of things are considered, and when you're, then maybe to move into the next piece of it, you have children that we have this tremendous opportunity to help them learn more effectively and enable a teacher to be more effective in their role and reach more students. But then as these students start engaging with the platform, how real do we want to make it? How much do we want to make it like the teacher? I think we've seen some stories in the news, like the Moxie robot, when they stopped supporting this small desktop robot made for children, it was like kids lost their friend. So it's something that it's a big responsibility. And I think, so one of the things that we're looking at doing for this is to also enable the users to sort of modify the personality of the robot and try new things and see it more as a tool in these use cases where they still have this friend, but they know that it's not human, because this could be at a very vulnerable stage during childhood. So yeah, I think maybe a little all over the map on that answer, but it's just a flurry of thoughts after that question.
I won't, yeah, but I wanted to add to this, because like we talk a lot about physical safety with our robots, but I think what you're touching on here is the psychological safety being, equally important, if not in some of these environments. And I agree. Expectation setting comes from how your robot communicates, how it behaves, and how it moves around these environments. So being sure to set the right expectations of what the robot is doing, what it's there for, what it's capable of, and what it's not capable of, both in these kinds of emotional situations as well, is critical.
Yeah, I spoke with someone yesterday, another product designer that worked on a program to design an industrial robot, and he showed me a picture. I'm like, that looks like a power tool. That looks dangerous. It's exactly what it's supposed to do. That's perfect. And then on the totally other end of the spectrum, you want the one for children you want them to run up and want to hug it, right? Like it's the complete opposite effect, but it's so important.
I was going to add something really practical, which maybe fits into this social experience more than the industrial thing. As putting my sort of consumer products hat on, the thing I always like to think about deployment are the bookends of the experience that we maybe forget about. So it's the onboarding, and then what happens when you're not using the product as much? What happens to it? And I think this is really crucial with basically such a big hunk of hardware that's going to be coming into our lives, especially in social contexts. No one's going to read the instructions. So how can we design the expectations into the hardware, into the UX? How can we design these humanoids to explain themselves? How can we design these robots to explain themselves, not just at the beginning, but at several points throughout? How do we think about learnability of these interactions and evolving, especially if some of these features learn from us and then our expectations change? So it's sort of developing those sort of continued learnability throughout those sorts of interactions, especially as we start thinking about service robots where we maybe walk into a supermarket, a Home Depot, where that user isn't even going to go through any type of unboxing experience like a social experience or a 2-hour training session in a factory. It's just a, hey, do this thing for me. Like that's a really interesting, hard social, like onboarding learning challenge. So those are some interesting things to think about. On the other end of the experiences, like we're going to have this, what happens when, that story about the robots collecting dust in the corner of the factory yesterday on one of the panels because no one wanted to fix it. Where do these things live when they're not being used as much, especially in the home, in the classroom? Because they're not just a tool that we can wheel into the corner of the room. They look like entities. We're going to have a very human reaction to something that looks more human. How do we design for them to be out of action?
Absolutely. We just have a few minutes left, so I thought I would ask you all to, one, if you have any concluding remarks, but the final question is just, what mode will we interact with humanoid robots when they are omnipresent? Will we be talking to them? Will they be autonomous? Will we be typing to them? Will we want them to talk back to us? Is voice the ultimate way we're going to interact with these creatures?
Honestly, it depends on I'm going to give that answer. It depends on context. I mean, the short version is that humans apply social cues to our robots whether we like it or not. And so we have to, associate things with that. I mean, for all of us that have built and deployed a robot in any situation, the common things I always see is somebody will see your robot and they'll wave to it, and they'll expect it to see you and wave back. Or they'll reach out to sort of shake its hand, and there's this awkward, like, does it see me? Is it going to shake my hand? Is it going to do these things? And so, like, these are the entry-level things that people are going to walk up to and interact with a machine and sort of see it and decide that, oh, okay, in this scenario, like, what do I do? Can I wave at it? Can I communicate with it in this way? But to answer your question more directly, I think it's going to be multimodal. It's going to be all of the above. And in the scenario like of a robot, you get the benefit of you could probably talk to it. It's going to need to be able to understand social cues. It's going to be able to need to communicate social cues non-verbally. The example I gave before about walking into each other and having a dance in a hallway. Or, I think the example you gave of, the hand leading in that direction. The robot's got to be able to communicate, hey, I'm going to put that toad over there before maybe it starts the thing. So it's going to be all these sort of multimodal levels. I'm not even touching on the things that happen in the background. The integration lets it communicate in ways that we can't, And so I'm going to give the annoying answer of all of the above.
And I'll kind of add to that and just say, I don't think we know yet. I think just like how in prosthetics we kind of figured out things that, like, oh yeah, there exists 36 different ways to pick up an object, but there really exists like only one good way for, depending on how many degrees of freedom that you have. It'll be very similar with the way we interact with robots. So right now, one application of our hands that we've been seeing is sign language, and there's over 300 sign languages across the world, and so like that's not a typical way you'd expect to interact with a humanoid robot, but it's going to be necessary, right? And what's the conveyance back to the human? Is it going to be sign language as well, or do they have a screen or something on their face that just emits words out, and then you can interact with the robot that way? So I think there are going to be more and more different ways to interact with a robot, because like right now, like with Waymo, like you just summon Waymo, and now it's there, right? You just use a tap. So I think there's going to be a ton of different ways. I don't think we've hit even just the surface of it yet.
Yeah, I think that for me, I agree with what you guys are saying, and then like all of the above, it's gonna be all of those things depending on the situation. But maybe to Pip's earlier comment about the unboxing and like throw away the instruction manual. I mean, the expectation is that you can just take this thing out of the box and start talking to it, and that you'd be able to verbally just ask, hey, can you do this? How many facial expressions do you have? Are you able to count to 10 on your fingers? And what else can you do? I think that to me is the primary driving factor. And then for the professional who's using this as a tool, then maybe later it's like, okay, I want to download the app, and I'd like to get a bunch of data from the machine later that I can analyze. That's of course going to be important, but I see that primary communication method being verbal.
Pip?
I think this might be an area of adaptation as well. Even just looking at the history of user interactions, we've learned many different modes and become comfortable and fluent in these different ones. So again, that fluency may change as we start to integrate different types of interactive humanoids into our daily lives, and that change our expectation for different types of contexts and modalities of interaction.
We have a lot of exciting things to learn ahead. I hope you all join me in thanking our panelists. And thank you so much for your attention.
Thank you all so much. I'll take those from you.